Hello, class. Welcome back. Today, we're going to go ahead and continue. All right, we're going to go ahead and continue our current chapter, right? We are now in section 8.2, right? The z-test for a mean, all right? So here begins the z-test, all right? The formula for test value, right, can be found in the page for that section, which is page 419. Right, and please go ahead, and if you haven't done so, please go ahead and make sure you fully understand. You have read, right? You have read the problem, as well as you are familiar with section 8.1. Right, so our analysis, right, it's going to depend on our alternate hypothesis, right, how we define our alternate hypothesis. So, right, we're either going to be doing a one-tail test to the left, a one-tail test to the right, or a two-tail test, right? And it all depends on our alternate hypotheses, right? If you state that your alternate hypothesis is your mu less than a value, all right, that's going to be a left-tail test, right, to the left. If your alternate hypothesis is mu greater than a k value, it's going to be to the right, right? And last but not least, if your alternate hypothesis does not equal that k value, well, it's going to be a two-tail test, all right? We're going to go ahead and be a two-tail test, all right? And the general formula, all right, that we're going to be using moving forward, right, it's going to be, you're going to have your test value, right? And this here, it's going to be your observed value minus your expected value all over your standard error. All right. And again, you may find this in page 419 of your textbook. All right. So let's go ahead and get started. All right. So many people believe that the average number of Facebook friends is 145. The population standard deviation is 36.3. All right, a random sample of 46 high school students in a particular country revealed that the average number of Facebook friends was 160. At alpha given 0.05, is there sufficient evidence to conclude that the mean of friends is greater than 145? All right, greater than 145. So the first thing I want to go ahead and do is state my hypotheses and identify my claim. All right, so my alternate hypotheses. Let's go ahead and write that up here. My alternate hypotheses. It's going to be mu greater than 145, meaning my null hypothesis is mu equals to 145. All right. Okay. So I know that this is going to be a what test? A two-tailed, a one-tail left, or one-tail right? A one-tail right. Right, there's going to be a one-tail right. Right. And again, right, if you don't remember, let's go back to this here, right? We are choosing this one. Right, we're using that case. Right, greater than. All right, so I have that. Part B is to find my z crit. All right, and my z critical value. All right, my z critical value. All right, so let's go ahead and find out what that is. All right, how do you find z crit? Here, it's going to be based off of the alpha that's given to me, right? So it's going to be 1 minus alpha, all right, which is 1 minus 0.05. Right, that's 1 minus 0.05, and this is going to be 0.95, right? And please have your z table, your z table ready, right? Have your z table with you, right? So similar to before, right? We're going to be working backwards. The probability is 0.9500, and I'm looking for the z value, all right? I am, again, right? I am 0.950. I am here, right? I need to choose between these two, right? And we said, right, whenever you're stuck in between them both, you round up, So I'm going to be looking at this one, meaning the z-value that I'll be interested in is 1.65, right? It's going to be very, very important, 1.65. All right, so meaning z crit is 1.65, okay? Meaning, right, z.165 is here. It's there, right? Meaning anything greater than this would be inside that critical region, right? Anything greater than this. So any like say 1.65 and higher, right? Anything greater than that. All right. So I found my z crit, very nice. Now I need to go ahead and find my observed t value, or my observed z value. All right. So I'm going to get a value and I'm going to make an observation. All right. I'll go ahead and call this z observed. All right. The value I'm going to go ahead and be observing. All right. Let's go ahead and get that ready. Right, and the formula, right, to find this z, let's go ahead and keep it by the book, right? Let's go ahead and the z value, it's going to be the observed value, right, minus my mu, right, my expected value, divided by my standard error, right? So my standard error, right, is going to be mu sigma over square root of n. All right, so the standard error, right, is sigma over square root of n, right? So one thing you may want to find is, let's find standard error first, right? Let's go ahead and find standard error first. So, right, so one thing we probably wanted to do in the beginning is write out the givens, right? All right, let's go ahead and write out my givens. So, let's see here. The average number of Facebook friends, all right, I have that. I have a standard deviation, all right, and a sample size, all right. So let's go ahead and see here. My mean, all right, it's going to be 145. My observed value, all right, the value I'm observing is 160, all right. The number of Facebook friends was 160. Right, my sigma, my standard deviation is 36.3. My sample size, a random sample, 46 students was chosen. 46, very nice. Right, so to find my standard error, right, this here would be 36.3 divided by the square root of 46. All right, let's go ahead and see what that gives me. Right, I got 5 points. Let's go ahead and do let's do intermediate steps. Let's do 4 decimal places, right? 5.3521, right? So, and if you want, you can just plug everything in, right? I would just state, if you're going to plug in the standard error all at once, just please put the top in parentheses and then the bottom part in parentheses as well when you're putting it into your calculator, right? Parentheses played a huge part, and it just plays a huge part in general, right, for our answers. So please go ahead and do that. If you were to do the top value, right, x minus mu, this would be 160 minus 145, right? And that gives me 5, 10, 15. All right, so my answer should be, all right, approximately less than 3, all right, close to 3, but less. All right, so let's go ahead and plug that in. The value of with z-test that I'll be observing is 36.3. I got 2.8 8. Oh, right. We'll go ahead and do these z values to 2 decimal places, right? Go ahead and keep this to 2 decimal places. All right. So you, the mathematician, are going to make an observation, right? Let's go ahead and bring the table that you drew here with z crit. All right. Is this value, your observed value, is it to the left or is it to the right? All right, one way you could see it as is, remember, this is just a number line with 1, 2, 3, and 4. All right. 1.65 is approximately here, and it includes everything there. So anything within this region is a crit. It is in the critical region. Well, 2.80 is definitely in that region, right? It is in the green zone, right? So, all right, how you would make the decision, all right? The decision you would make is, do you reject the null hypothesis or do you fail to reject the null hypothesis? So, yes. And yes, I would say T observed is in the crit. So reject null hypotheses, right? You may be asking, right? You may be saying, hey, you had mentioned something about entering yes to a question. Yes, right. And that part is, what was the question that was being asked? All right. It's up. Let me go and see if I can highlight it. Should be able to highlight it. What I'm talking about. Is there sufficient evidence to conclude that the mean number of friends is greater than 45? Right. As the mathematician, feature scientist, right, feature statistician, right, you would say yes, z observed is in z crit, so reject the null hypothesis, all right, and we said you're going to answer yes, right? So if it's in the region, right, if it's in the critical region, you're going to answer yes to the question, right? So you're going to state yes, there is sufficient evidence to conclude that the mean number of friends is greater than 145. All right. Sure, I skipped a few, omitted a few letters here and there, but you get the idea. All right. So let's go ahead and do another one. These are fun. I like these. All right, so you have another problem here. All right. Sick days in bed, right? I'll go ahead and pause it. I'll go ahead and let you read the question. Okay. So again, right, one of the first things we may want to go ahead and do is, right, just have it, right? It's go ahead and write the given values, right from the start. All right. Your mean observed was 5.2. Takes a greater, right? Your average will then be 5. Your standard deviation was 1.1, and your sample size was 30. Very nice, all right? So first, right, let's go ahead and find out for part A, let's find me my alternative hypotheses, all right? What am I looking for? Where is that? All right, it's greater than 5, all right? There we go. All right, researcher wishes to see if the average number of sick days is greater than 5. Yes. All right, so this here would be my greater than 5. Therefore, must mean that it equals to 5. All right. Very, very nice. So for B, all right, I need to go ahead and find my critical values, right? So one thing you may, again, right, what kind of graph are we going to do? It's greater than, all right, because the question says the researcher wishes to see if the number of sick days a person has worked per year is greater than 5. All right, so it's going to be greater than. That's the region I'm looking for. All right. So again, right, let's find our z crit, right? Let's find z crit. All right. So this is 1 minus alpha, right? What is my alpha? 0.10, right? Right, so the value I'm looking in my table is 0.90, right? I'll go ahead and try to find it. 0.9000, right? Very nice. I see 2 of them, right? I go ahead and see 2 of them. Clearly, right, I'm not smack in the middle, right? I'm not exactly in the middle. It is closer to one of them, right? Is it close, right? One value is 0.8997 and the other one is 0.9015, right? Which one is it closer to? It's closer to the one on the left, right? So my z crit is 1.28, right? It won't be 1.29. Only if it was smack in the middle, but it's not. All right. All right, so that is my critical value, meaning, let's go ahead and draw that, right? Go ahead and draw that. This here is z is equal to 1.28. And yes, I need you to draw this table in your exam, right? So all this work that I'm showing is the work that you would have to go ahead and show, right? And it's going to be asked a specific, that specific way. Right. That's my z crit, right? So let's find our compute the test value, right? So right, you can call it z test val, or right, for the z test, some use the observed value, the observation you're going to be making, right? And again, that is x bar minus mu over your standard error, right? Go ahead and plug those values in. Right, go ahead and plug those values in. So in other words, you're looking for just like I said, right, if you're going to put this in the calculator, put a parenthesis here, divide, open a parenthesis, do 1.1 over the square root of 30, and then do that one again, all right? And the value you should get is 1.00, right? And then you're gonna look at your observation, right? Go ahead and make an observation. This is right smack in the middle. This is z equals 0. Hey, I see this equals 1. It's here. All right. All right. So for D, you would state fail to reject hypotheses. All right. Or in other words, do not reject hypotheses, right? So it's a no, it's not in there. So that means you're going to answer no to the question, right? The question asks if the average number of sick days a worker takes per year is greater than 5. So right for E, you would say no, the average number of sick days a worker takes per year is not greater than 5, right? There is no evidence to support that claim, right? There is no evidence to support that claim. Very nice. Okay. So for our next problem here, we have dress shirts. Right, I'll let you go ahead and read the question, right? As well as write down the values, right? Just go ahead and write down the values. right? In a previous study conducted 7 years ago, a man owned on average 16 dress shirts. All right, go ahead and read all of that. So let's go ahead and get the standard deviation of the population is 3. Okay, very, very nice. Right, a researcher wishes to see if the average has changed. He selected a random sample of 43 men and found that the average number of shares that they own was 15.2. All right, so this is my average. Right. Average of my sample mean. Let's go ahead and find the hypothesized population mean. All right, what do we think that is? That'll be 16, right? Okay, at alpha equals 0.10, is there enough evidence to support the claim that the average has changed? Okay, so since we're talking about dress shirts, all right, the amounts of dress shirts that are being owned, all right, again, right, my mu, right, and it all comes back to the mu value, right, to the mu value of the question, all right. So the average has, so in other words, I want to know if it's, so it doesn't say greater than, there's no less than, it's strictly, I want to know, is it 16 or is it not 16, all right? So for my alternate hypothesis, not 16, all right? Meaning that my null hypothesis will be 16, right? So again, it's in the question, right? It is embedded in the question, right? Okay, right, so this was my part A. All right, for B, let's go ahead and find B, right? It is critical value, all right? Go ahead and be my critical value. And since I'm dealing with a two-tailed test now, right? This is going to, whatever value I get, it's going to be plus or minus, all right? So here I have 1 minus 0.10, right? Which is going to give me, let's go ahead and see here, all right? Ah, there we go. What comes back to that, right? One second here. I was looking for a work that we had done for a two-tailed test in 7.2, right? So you may want to refer to your notes on 7.2. Remember these steps, right? Whenever we were dealing with Z alpha over 2, if you were given a percentage, you would follow these 5 procedures, all right? Since your alpha was already given, right? We skipped step 1 and we skipped step 2, meaning you're able to go straight to 3, 4, and 5, right? You have your alpha. Your alpha is for a two-tailed test, right? Remember, this is for a two-tailed test for 0.10, right? Right, meaning if you were to go to 3, you can find alpha over 2, which is 0.10 over 2, which is 0.05, meaning you would go to 1 minus this, which would give you 1 minus 0.05, all right? 1, right? Your 1 minus 0.05, which would give you 0.9500, right? And we said here that then you would go ahead and find a Z value, right? By working backwards, right? From your Z table. All right, you'd notice that 0.950 is between these two values, exactly in between. So you're going to choose the greatest one, right? And round up, meaning you're going to look at 1.65, right? So your Z crit is going to be 1.65, but hey, remember, again, it's a two-tailed test. It's going to be plus or minus, all right? It's going to be plus or minus. Remember, and again, right, this is I know it's been a while, right, but this is a 7.2 refresher. All right, and remember, this is applicable with two-tailed test. All right, so I found my Z crit, all right? My Z crit was plus or minus 1.65 because it is a two-tailed test and I need to take both of them into consideration. All right, I'm going to need you to draw. All right, I know we're not. What was I going to say? So you got one there and one there, negative 1.65, 1.65. All right, so we found my critical values, right? My z crit. So now I'm going to go ahead and find my observe, right? I'm going to go ahead and make an observation. All right, my z observed will then be x bar minus mu over sigma over square root n. All right, go ahead and plug those values in and let me know what you get. And you should get a negative 1.75. Right, negative 1.75. Is negative 1.75 in that critical region? Yes, right. It is to the left of this, right? It is somewhere there. All right, so it is there. All right, it is there. All right. So for D, right? Yes. So reject your null hypothesis, right? It is in the region. All right. And as a statistician, the scientist that you are, all right, you're going to go ahead and answer the question, right? So let me kind of just do this. Yes. Oh, that is so small. So you would answer yes to the question, right? So yes, there is enough evidence to support the claim that the average number of dress shirts is not 16. Right. Very, very, very nice. Very, very nice. Okay. Last but not least, right? Speeding tickets, right? I'm going to let you write that down. Okay. See, what can we derive from this? I get my sigma, right? 13.42. And one thing we also want to include now is my alpha, right? To have my alpha, right? Motorist claims that the Southborough Police, Borough Police issues an average of 60 speeding tickets. Is there enough evidence to reject the motorist's claims? All right, so that mean that it's going to be this value here, right? Awesome. And then x bar and an n. How do I find this given just raw data, right? Well, you know how to solve this, right? This is unit 1, right? Your n is just going to be the amount of values that you have in here. All right, you can do 3 times, was that 4, 5, 6, 7, 8? 3 times 8 plus 3, all right? What's that going to give me? 3, 8, plus 24, plus 3, 27, right? 7, and how do you find x bar? Remember how to find x bar? X bar was the sum of all my x values. Oh, my puppy's taking my shoes. Oh, give me 1 second. And we're back. Those shoes are hers now. And so we said to find the I'm sorry, the x bar, right? We found the average, right? The mean. It is the sum of all these x values over n, right? So this is something you can plug it into your calculator, right? So go ahead and sum all those values up, right? Meaning you're going to do 58 plus 87 plus 48 plus all the way till you end up with 57 plus 60 all over n, right? All over 27, right? And the x bar that you found, right, would be this here should give you 1617. I computed this correctly over 27, right? Which is going to give me 59.89, right? 59.89. So that is my x bar, right? So this here is awesome. Okay, this was a 5, right? So let's go ahead and get started with identifying my hypotheses, right? A, so we got H naught and H1. Right, let's go ahead and find H an average of 60. Is there never to make this claim? So, okay, cool. Right, so that one has to be not 60, therefore this one has to be 60. All right, so there goes okay, making sure I mentioned correctly. So yeah, so for this one, it's also going to be a two-tailed test. All right, this is also going to be a two-tailed test. All right, again, right, if you don't remember, hey, how do you determine this? Go over this part of the video again, right? Since it's not equal to that value, it is a two-tailed test. All right, so for B, all right, let's go ahead and compute my test value. All right, let's go ahead. Oh yeah, and if you notice, this is going to be a little bit different than the previous values, than the previous 3 problems, right? This is why I chose it. What you need to go ahead and do here is do the p-value method, right? There'd be a different method, right? So again, right, you're still going to go ahead and compute the same z value, right? So here, what I'm going to go ahead and do now is not find my critical value, my t-crit, right? It's going to go ahead and find my test value, right? My test value. I observe. Right. This here is going to be my x bar minus mu over sigma over square root n, right? Remember, again, this is standard error, right? Again, that is standard error. So I'll get 59.89 minus 60 all over 13.42 divided by the square root of 27, right? Which is what, 3 square root of 3, right? Heat here. And when we go ahead and do that, we should get negative 0.04, right? This here is going to go ahead and play an important part. There you go. Okay, now, right, what are we going to do now, right? What are we going to do now? Now, right, since we're doing the p-value, right, your p-values are what's inside, right? It's inside the grid of your z table, all right? Those probability values, all right? So let's go ahead and do that, right? I'm going to want to go ahead and find. Let's see what would work. There you go. All right, I'm going to go ahead and find, what was I going to find again? Negative 0.04. Negative 0.04, negative 0.04, negative 0.04, that value right there. That is the p-value I'm looking for. All right, again, negative 0.04, 0.4840, 0.4840. All right, so the value I got here, right, was 0.4840, right? 0.440. But since one thing I need you to remember is, if you are doing a two-tailed test, right, I need you to double that, all right? And this is when we're doing a two-tailed test, all right? So you're going to go ahead and multiply this by 2. All right, so this is going to be 0.4840 times 2. And we should get 0.968, all right? 0.968, all right? Right, and there's one more thing I need you to go ahead and do, right? So your p-value, right, for a two-tailed was 0.968. Okay. What we know about the area, I know something about the area under this curve, right? And I know the area under the curve. I know the probability under the curve, right? We said, what determines this is alpha, right? Determines this is alpha. If your alpha is 0.05 and I'm dealing with a two-tailed test, then that means the total area, right, would be 0.05 for both of these together. But for each one, what would that give me? That is 0.025, right? 0.025, right? Meaning my area is 0.025 here. Area is 0.05 here, right? Very, very, very nice. Right, so that's a visual representation of what we're doing, all right? So, and if we remember 8 point, where was this at? This part here, right? At the end of 8.1, I said emphasis on this. All right, let's go ahead and bring that back. All right. What was your A vat? What was your alpha? 0.05. What was your p-value? 0.968, right? Meaning, right, so make the decision. So, right, compare your p-value and your alpha. My p-value was here, my alpha was here. What do you notice? P-value is greater than, right? So since p alpha is greater than p is greater than alpha, specifically, comma, I need you to go ahead and give me those values. 0.68 is greater than 0.05, right? You're going to fail to reject or do not reject no hypotheses, right? Right, and if you wanted to write this, let's go ahead and write this scientifically, right? I didn't mean to write blah like that. I just want to go ahead and make this larger. Just do 28 again, right? Take the blah out, right? No, since the fail to reject no hypotheses, there is not enough evidence to reject. So you want to answer no to the question, right? You would go ahead and answer no to the question. Is there enough evidence to reject the motorist claim? No, right? No, there is not. So that is all I have all for you today. All right. Be sure you fully understand what we're doing here. You know that you get the flow of these steps that I'm doing, right? If you notice, right, there's a flow to all of these. All right. There's it's a flow, right? There's a process. It's a step-by-step process, right? And that's how I would expect you to solve these upcoming other problems. All right. So again, if you have any questions, please go ahead and let me know. Hope you're all going to tutoring. Remember, I am also available for any assistance. And thank you very much for your time and hope you enjoy the rest of your day. Thank you for watching.